Hi, so I'm going to go through the corrections of the homework from yesterday and go through nice and quickly, hopefully, starting with question 1 on the page that was listed. So question 1 asks, how many ways can the letters of the word 8 be arranged if all the letters are taken each time? So we're making different arrangements of 1, 2, 3, 4, 5 different letters, and we can do it using our pigeonholes. There's 5 of them, 5 choices for the first, 4 for the second, 3 for the third, 2 for the second last, and 1 for the remaining one. And that, of course, is 5 factorial, or 5 by 4 by 3 by 2 by 1, which calculates to be 120. You can jump straight to just writing down 5 factorial if you want. You don't have to show the process of how you came with that. Okay, question 2. How many different arrangements can be made using all of the letters of the word recant? A recant has 1, 2, 3, 4, 5, 6 letters. So that means we're going to have 6 factorial possible combinations, and that is 6 factorial 720. 720 different arrangements. Question 3. How many, I apologize, we're not finished that. So part 1 then asks us, how many begin with the letter R? So now I do need to use my pigeonholes. I've got 6 of them, and there's only one choice for the first one because that must be the letter R, leaving me with 5, 4, 3, 2, 1, or 1 times 5 factorial, 120 choices. Part 2. How many of the arrangements begin with R and end with T? So now I have reduced my options to only 4, 3, 2, 1, which is 1 times 4 factorial times 1, which is, double check, I think it's 24, but we can quickly check in the calculator. Yeah, it's 24. And if I'm going a little bit quickly, you can just pause the video and check that you understand, or leave me a question if there's something that you don't understand. Question 3 now. How many different 4-digit numbers can be formed using the digits 3, 4, 5, 6? It says if no digit can be repeated. That just means that we're not doing that we run out of choices. Once we've used the first one, we're then down to 3 choices, to 2 choices, to 1 choice. So again, that's going to be 4 factorial or 24 different arrangements. Those are my answers. Now, question 4. How many 3-digit numbers can be formed with the digits 1, 2, 3, 4, 5. Now things are getting a little bit more complicated. I need to use my pigeonholes. And I only have 3 pigeonholes because I'm forming 3-digit numbers. There are 1, 2, 3, 4, 5 different options to choose from. So I have 5 options for the first digit, leaving me with 4 options for the second digit and 3 options for the third digit. So this is a little bit like our restrictions, very slightly different because we're not using all the numbers this time. And when I multiply those together, I have 20 by 3, which is 60 different possibilities. There's some follow-up questions then. Part 1 says, how many of these numbers begin with the digit 5? So again, I've got 3 pigeonholes. but I only have one choice for the first one, leaving me with 4 choices for the second one and 3 choices for the third, meaning that there are 12 3-digit numbers from those choices that start with 5. Part 2 then says, how many of these numbers are greater than 400? So greater than 400 means the first digit is either 4 or 5. Sorry. So the first digit could be a 4 because, for example, 412 would be greater than 400, or it could be a 5 and that would be greater than 400 as well. So now when I look at my pigeonholes, I actually have 2 choices for the first box. And now I've taken away one of the 5 digits, so I have 4 for the second and 3 for the third. And that means that I have 24 possible outcomes using those 5 digits that would be greater than 400. Okay, and finally question 5. Let's move on to a different sheet. Question 5. How many different arrangements can be made using all of the letters of the word Poland? 1, 2, 3, 4, 5, 6 letters. So that means 6 factorial, which is 720 arrangements. How many of those arrangements begin with a vowel? Now I need to use my pigeonholes. There are 6 letters and I'm using them all up. So I have 6 boxes and there are 2 vowels in Poland. So 2 choices for the first box, leaving me with 5, 4, 3, 2, 1 for the remainder. And that calculates to be 2 times 5 factorial, which is 240. I'm just using the fact that I've already calculated 5 factorial earlier and that was 120. So I happen to remember it, but you can just use your calculator. How many of these arrangements begin with P and end with D? Again, my 6 boxes, but my restriction means that I've only got 1 choice for the first letter and 1 choice for the last letter, leaving me with 4, 3, 2, 1 choices for all of those in between. And that's 1 times 4 factorial times 1, which is 24. And the third, how many of these arrangements begin with a P and end with a vowel? So beginning with P and ending with a vowel, meaning I have 1 choice for the first letter and 2 choices for the last letter. 4, 3, 2, 1 in between, and that's 1 times 4 factorial times 2, which gives me 48 possible arrangements that satisfy that condition. Okay, so those were the straightforward questions, and then I'd asked you to do 2 slightly more difficult questions. Question 12. How many 4-digit numbers can be formed using the digits 4, 5, 6 and 7 if no digit can be repeated? So that's going to be 4 factorial arrangements, 24 arrangements. How many of those numbers are greater than 6,000? So if they're greater than 6,000, that means that it begins with either 6 or 7. And using my pigeonholes, I know that I have 2 choices for the first digit, followed by 3, 2, 1 for the others, and that is 2 times 3 factorial, or 2 by 6, which is 12. Part 2, find the probability that the number is greater than 6,000. Well, that's going to be the outcomes that match being greater than 6,000 divided by my total outcomes. And that's 12 out of 24. Exactly half of the outcomes will be greater than 6,000. I did want one where we were asked about probability. And finally, question 14. Shauna has 5 counters and she places them in a straight line. There are 5 different colours: red, white, green, blue, and yellow. How many different arrangements are possible? 5 factorial. You can do pigeonholes if you want to. That gives us 120 total possible arrangements with those counters. In how many different arrangements is the first counter blue? So you can see that we're treating these just like they're letters in a word as well. 4, 3, 2, 1, which is 1 times 4 factorial, or 24. So in 24 arrangements, the first counter is blue. In how many different arrangements is the first counter blue and the fifth counter green? Restricting my possibilities 1 and 1 like this. And I have 3, 2, 1 choices for the other 3 counters, giving me a total of 6 arrangements that satisfy those criteria. Okay, so that's the homework corrections. Of course, let me know if you have any questions, and we'll go on to today's work in a separate video. Thank you.